When you solve an equation, you always want to collect like terms on a side of the equal sign. So this 7x minus this 4x needs to be collected before you do anything. So please, 7x minus 4x is 3x, and then bring that minus 8 down, and your left side is ready to go. On the right hand side, 2 and 10 add to be 12. You do have that negative x there. I'm going to put that down first and then the positive 12. And now I'm ready to isolate the variable x. I like to focus on x first. So I'm going to add x to both sides of this equation. It's a 1x, don't forget. And then I will work on the constants. So the 3x and this 1x adds to be 4x. And I'm going to bring down my minus 8. Bring down my equal sign, trying to be very organized. Bring down your positive 12. Again, I'm always trying to line up my equal sign to make sure it stays in the same spot and I don't move it. And now I want to isolate the 4x. So to do that, I'm going to add 8 to both sides. And I'll have 4x equals 20. And now to solve for x, I'm going to divide both sides by 4 to get x alone, and I find out that x is equal to 5. Please remember, you should check this answer in your original equation to be sure that it works and it gives you a true statement when done. Let's look at this next one. This minus 4 is in front of a set of parentheses, and I've got to distribute it to both of those. So I've got to distribute that minus 4 times the binomial. I'm not going to forget this 3x, so I'm going to bring it down first. And then the minus 4 times x is a minus 4x. And the minus 4 times a minus 3, right here, minus 4 times a minus 3 is a positive 12. On the right-hand side of this equation, I have 3 times x is 3x, and 3 times 2 is 6. And then just don't forget to bring this 2 over here. Let's now collect our like terms. So on the left-hand side, I have 3x minus 4x is a minus 1x. You don't need to write that 1, but sometimes it's helpful. On the right-hand side, I have 3x, and then this 6 and 2 add to be 8. Now I'm ready to isolate that variable x. I like positive numbers in front of my x variable, so I would prefer to add 1x to both sides versus subtracting 3x from both sides right now. So that'll give me a 4x right here. And then I'll turn to subtracting 8 from both sides. So now I'm going to subtract 8 from both sides. And I have 4x equals 4. 12 minus 8 is 4. And then finally, you'll divide both sides by this 4, and you're going to find out that x equals a positive 1. Again, please don't forget to check that. When there's a minus sign in front of a grouping symbol or a set of parentheses, I'm going to use red for this. This 3 minus and then in parentheses, I'm going to erase that. That minus sign could be thought of as a negative 1 times what's inside these parentheses. Essentially, you need to add the opposite of the 5y and the 3. So that'll become a minus 5y and a minus 3. Now, I can't forget this 3 from the original part of the problem. I'm going to bring down the 3y on the right side of the equal sign, and then this negative 4 times, or a minus 4 times 3 is a minus 12, and this minus 4 times 2y is a minus 8y. And now let's go ahead and collect our like terms on the right-hand side. So 3y minus 8y is a negative 5y minus that 12. On the left-hand side, I have this positive 3, I'm going to use arrow, and this minus 3, which adds to be 0. And so I just have the negative 5y left. Now, if you're looking at that going, uh-oh, what should I do? That's good. You should be looking at that going, oh no, how can I solve this? Because how could you on the left-hand side come up with a number for y where you could multiply that y by a negative 5. But using the same number on the right-hand side, take that number, multiply it by a negative 5, and then subtract 12 too? You know, that doesn't make any sense. Well, let's say you didn't notice that. Then let's say that you said, oh, I'm going to solve for y, so I'm going to add 5y to both sides. So you didn't notice something peculiar was going on, and you have 0 on the left, and oh look, the y's are gone over here too, and a negative 12 on the right hand side. Oh my, this is not a true statement. 0 does not equal a negative 12. There is no solution to this problem. There is no way this would work. Let's see what the other problem will bring. So I've got to distribute the 4 times the 3 and get 12. And 4 times the minus 5x is a minus 20x. On the left side, 10 minus 7x. So I'm trying to isolate the variable. I choose to either add 7x to both sides or add 20x to both sides. I think I'm going to add 20x to both sides. I just like to keep my coefficient in front of x positive, so that's why I did that. Don't forget to bring down your 10 here. And a minus 7 plus 20 is 13x. Now I've got to isolate the variable, that 13x term, so I've got to get rid of the 10. And so I've got to subtract 10 from both sides, and I've got 13x equals 2. And then finally now I'm going to divide both sides by 13. So let's show I'm going to divide both sides by 13, and I get a solution of x equals 2/13. Not enough room to check this. I may come back and make another clip here, but you really should check the value of 2/13 in the original equation to see if it works. In introductory algebra, when we have an equation to solve that is not a linear equation, because this problem has an exponent of 2, we have a quadratic equation, and the means that we've learned to solve a problem like this is by factoring and the zero product rule. So this is a trinomial that needs to be factored, whose coefficient in front of the x squared term is a 1. That one's a little bit simpler problem to be factored because I'm looking for two numbers whose product is the negative 10, and I want those two numbers to add to be a negative 3. So I believe I'm talking about a negative 5 and a positive 2. Their product is a negative 10, and they add to be a negative 3. And really then, you just need to factor this trinomial into the product of two binomials where you have an x in the front of each of those because their product is x squared, and one's got to have a minus 5 and the other's got to have a positive 2. And now we use the zero product rule, which says if you have two or more factors that are equal to 0, that any one of them at any given time would be equal to 0 for this statement to be true. So either x minus 5 would be equal to 0, and we'd add 5 to both sides, and we'd find one of the solutions, x is 5, or we would set x plus 2 equal to 0, and we'd subtract 2 from both sides and find out that the other solution for x is a negative 2. I'm just going to take one of these really quick, and I'm going to check the positive value in the original equation, which was x squared minus 3x minus 10 equals 0. So if I wanted to put a 5 in everywhere I saw x, I'd have a 5 squared minus 3 times 5 minus 10. And order of operations expects that I do the work with the exponents first, so 5 squared is 25. Since I'm working left to right now anyway, I'm going to go ahead and multiply the 3 times the 5 and get 15. And then I'm going to work left to right, and 25 minus 15 is 10. and 10 minus this 10 is 0, and I can say, yeah, I got that problem correct. And I do the same thing with the negative 2. I would substitute in anywhere I saw x. Let's do this next equation. I'm going to erase this. So in this next problem, it's called the zero product rule. It's not called the 6 product rule. So I have to subtract 6 from both sides of this equation. So the left side of this is going to be the 5a squared minus the 7a minus the 6 equals 0. And we learned a special way to factor a trinomial that has a 5 in front of the squared term, and that was to take that coefficient and multiply it by the constant, the negative 6. So 5 times a negative 6 is a negative 30, and I'm looking for two numbers whose product is a negative 30, and I want those two numbers to add to be a negative 7. And I'm going to quickly get at those two numbers. It looks to me like they have to be a negative 10 and a positive 3. Some of my other videos have talked about how to go through the process of finding these two numbers. But these two numbers also, a negative 10 and a positive 3, do add to be a negative 7. And what we do is we replace this term right here, this minus 7a, with a minus 10a and a positive 3a, because isn't that indeed just a minus 7a? And I got that minus 10 and that 3 over here. That's where I got my minus 10 and my positive 3. But now I'll bring down my 5a squared and my minus 6, and I am now ready to factor this by grouping. So I'm going to group those two and these two and take out the greatest common factor out of each group. So in the first group, the greatest common factor is a 5a, and I'll need an a here minus a 2. And the greatest common factor in the second group is a 3, and I'll need an a minus a 2. And then finally, if this is factorable, then these must match, and the two binomials that will result will be this 5a plus 3, that'll be one of the binomials, and then the other binomial will be the a minus 2. And now, having finally factored the trinomial, which is equal to 0, I can set these two factors equal to 0. I'm going to get rid of this table right now. I can set 5a plus 3 equal to 0 and subtract 3 from both sides of the equation, and then divide by 5. So there's one of my solutions, is a negative 3/5. And then I can set the other binomial, the a minus 2, equal to 0, and I can add 2 to both sides and find out that the other solution for this problem is a positive 2. So here's my first and my second solution. We'll often write that as a set. We'll say that a negative 3/5 comma 2 is the set, so braces, of two numbers that work in that equation. These two problems are proportions. A proportion is just two fractions set equal to one another that form a true statement. So isn't 2/4 just equal to 1/2? So that's two fractions set equal to one another that form a true statement. And one of the things that we know about proportions is that their cross products, 2 times 2, is equal to 4 times 1. 2 times 2 is equal to 4 times 1. They're both equal to 4. So in a problem like this, one of the easiest things I can do for myself is to set these products, 36 times x, equal to a negative 14 times 18, negative 252. when we divide that by 36, 252 divided by 36, now remember it's negative, it's a negative 252 divided by 36, x would equal a negative 7. So again, we could check that. I'm sure you probably see that, let's go back to the original problem, but you probably see that 18 got multiplied by 2 to get the 36. So, you know, what number here gets multiplied by 7 gets multiplied, I'm sorry, a negative 7 gets multiplied by 2 to get this negative 14. So you might have been able to observe the answer. In this next problem, I need to take, I like to put the variable first. So I have 0.3x equals 6 times 45. I'm just going to write it as 45 times 6. That's equal to 270. When I divide 270 by 0.3, x is equal to 900. Again, please don't forget that you could check these. You could even just take a calculator and put in for x in the original equation. You could take and see if 6 divided by 900 is the same thing as 0.3 divided by 45. So you could check those, just type them in and see if it will give you the same decimal equivalent. When solving a linear inequality in one variable, your biggest thing to be cautious of is if you ever have to divide by or multiply by a negative number. That will happen in number 28 here. I do not believe it'll happen in 27. So otherwise you treat it like an equation. Basically, you take this negative 2 times this 5 and get a minus 10, and this negative 2 times a 4x and get a minus 8x, and then just don't forget to bring this 10x down. That's commonly the dilemma, and then less than or equal to 8. So again, we're solving this equation, so we're going to collect our like terms on the left side of this inequality. 10x minus 8x is 2x minus the 10. And then we got to get the x term alone by adding 10 to both sides. And then finally, we're going to divide by 2. 10 and 8 is 18. So we'll divide by 2 to find out that x, our solution for x, is less than or equal to 9. So somewhere on this number line, you just stick a spot that's going to represent, I'm going to do it over here to save myself some room. You put a 9 on here, and you can either use a colored in circle, or you could use a square bracket, but you have to show me that the values that work for this inequality are values that are to the left of 9, because they are less than 9 or equal to 9. And the interval notation for this, in this direction, you're going out towards a negative infinity. So the interval notation is a negative infinity comma 9. And you have to use a square bracket right here because this was, original problem was a less than or equal to problem. So the square bracket represents the equal to. Now in number 28, when you distribute, 2 times x is 2x, and 2 times 1 is 2. So we have 2x plus 2 minus that 6x is less than or equal to a negative 18. And then your like terms are 2x minus 6x is a negative 4x. Ooh, that's going to cause us a little bit of trouble. Don't forget your plus 2. And then now let's get that minus 4x alone by subtracting 2 from both sides. And we'll have a negative 4x is less than or equal to a negative 20. Now right here is the problem. When you divide by this negative, when you divide by this negative 4 right here, this right here has to flip to be that. Instead of a less than or equal to, it's got to be a greater than or equal to. So we're dividing both sides of this inequality by negative 4. And then our values for x, I'm going to put it right down here. x is greater than or equal to a positive 5. A negative 20 divided by a negative 4 is a positive 5. So pick a spot somewhere here on the number line. Either color in this circle, or I do want you to know that you could use a square bracket, because that tells me that you understand that it's equal to 5 and then anything greater than that 5. And then the interval notation accordingly then would be this 5 comma on out to a positive infinity. Again, it can be the square bracket, or it can be a colored in circle right here. I'm going to go ahead and erase this and just show this right here. That 5 could also have this colored in circle right here and tell you to go that way.